Makes perfect. Practice makes perfect. Okay, so you guys were just graphing this. You were graphing. I'm not going to do it algebraically. We're just going to do it graphically because we did it algebraically back here just to see the connection, okay? So this is an equation. This is not a system of equation. It's not two equations. It's one equation. When we solve it like a system, we set one side equal to y, 2x plus 6. Does everybody see where I'm getting the 6 from? Okay. Then we set the other side, y equals negative 3x minus 4. Now what I've done is I've taken an equation with one variable and I've made it into two equations so that I can graph it. Okay. The graphing looks like this. Positive 6 is my y-intercept. My slope is 2. That means I rise 2, run 1. Or rise negative 2, run negative 1. Negative 2, negative 1. You know, so now I have my line. That's how we graph our line. And that one right there is the y equals 2x plus 6. Now I want to graph the other line. I start out y-intercept negative 4. I'm going to use a negative 3 over 1, right? Rise over run. Negative 3, I go down 1, 2, 3 over 1. Or I go up 1, 2, 3, backwards 1. If I go up positive 3 over negative 1, that's the same thing as a negative 3. So I connect my points here, and I want to know where they meet. Well, they meet at an ordered pair, but my solution is only x equals. So my solution here is just an x, because I know there's an ordered pair, but if I plug in that x, I'm going to get that. That's how we do our check. So our solution is what? Negative 2? X equals negative 2? So the difference is I'm not going to say negative 2, 2. I'm not going to say that is my solution because I only care in this case about the x value because I have an equation with only x in it. So that's how we're used to solving it algebraically. We're just using the same idea to solve it graphically. Okay? And you can do this on the calculator and on Desmos as well, but we're practicing graphing lines. Okay, note, remember that a function is simply a series of operations on x and input. So you may not see the y variable, but is used to graph the output. Because see, they're saying I could have also said this is f of x equals and g of x equals. So I can name these using function notation. This was f of x and this was g of x. Okay, another name for input is, anyone know? Domain, I'm going to say. Domain or x. Yeah, x. Yeah. Another name for output is the range or y value. X value. Values, say. Remember that your original equation, or what your original equation looks like, right? That was the original equation is an equation in one variable. If it only involves one variable, your solution will only be the value of that variable. That's why we said the solution here is x equals negative 2. Always look back at the original question to verify your solution matches the blank of the question and what is being asked. Anyone know? Answer, sure. Sounds right to me. You'll look on the PowerPoint. Maybe it's different on the PowerPoint. Okay. Right. Graphing equations with a graphing calculator. I'm going to show you right now. I'm going to demonstrate my graphing calculator because look at this equation right here. This equation has a lot of decimals. It'd be even worse if it had some fractions in it, right? Well, decimals are equivalent to fractions. Okay, so what we're going to do on the graphing calculator is to graph, we're going to go to y equals. And by the way, you can also use desmos.com, okay? So what we're going to do is we're going to go to our y equals menu. On your y equals menu, you're going to clear out anything you have. So you're going to go to y equals. You have to, in order to graph, everything has to be set to y equals. So step 1, y equals, okay? And then step 2, input, this is on your calculator, input each side of the equation. And realize this might be worded differently on the PowerPoint. Input each side of the equation for y1 and y2. So this is the first equation, y1. This is the second equation, y2. And if you're going on to Math 95, you will absolutely need a graphing calculator. So what we're going to do is we're going to punch that in. Negative 0.87x plus 1.14. Because wouldn't that be a pain in the butt to try and graph a y-intercept and a slope like that? It would be. Okay, then I go to y2. I go to the second line. Notice I can graph multiple equations at the same time. I'm going to plug that in. I don't even need to distribute. Negative. Now, it's important if you have a negative to use negative, not minus. So negative 2.69 times, parentheses, x. There's our x button on the TI-84. Plus 4.05 parentheses, and now I'm going to push graph. Once you input it, you're going to graph it. Okay? And we can see, you have to be able to see. Now, you sometimes have to change the window around, and that's why I recommend if you don't have a graphing calculator and you're doing problems on Connect Math, you can simply put this into Desmos. I can't show Desmos here because I don't have like a tablet or whatever, but you just have to be able to go online. You could probably go on your phone even. I want to find that point of intersection. On Desmos Online, you literally would click on it. This is a much more involved procedure to find the solution because we need to use this menu. So step 4 is to go second calculate. Okay, so second calculate. I don't even know if anyone's using these graphing calculators anymore, so maybe this isn't even useful, but hopefully it is. You see where do you think I'm going to find, which button is going to tell me the intersection, point of intersection, do you think? Oh, 5, because it says intersect. So 5, they want to know first curve, yes, enter, because you only have 2 curves. Second curve, enter, guess, enter. Okay, so you're going to push enter times 3. 3 enters. And then it's going to tell you the point of intersection. So remember, we want the solution. Who can tell me what the solution is based on my graph? Anyone see it? It's really tiny. That's why you can't see it. Negative 6.612363. We didn't round it. Okay, it's decimals. Why am I only putting the x value and not the y value down? Yeah. Remember, when I have an equation in one variable, I'm only solving for x. If I plug this x value in, I will get 6.892755 because that would be my check, right? You see what I'm saying? So only x, this is my solution. You're probably going to see some questions like this on Connect Math when you do that this weekend, aren't you? Very good. Okay, the TI company produces and sells calculators. Did you know that? Poor guys, because everything's going online. Okay, their cost to produce X calculators is this. So how much does it cost them? What's their startup cost? If you're opening a business, you have to start up. And then how much does it cost them per calculator? Can you see that from the cost? Yes, startup, just like the car, right? $1,830 for every calculator. Their revenue for selling calculators is R of X equals 120X. How much are they selling calculators for, you guys? Ah, that's exactly what I paid. How'd they know? That's exactly what I paid for this fancy one. It's nice because it has the color screen, you notice. Pitch for TI. Find the number of calculators they must sell to break even. Couple of different things to notice. This is going to come up in a lot of your math classes. You could find the profit, P of X, equals revenue minus cost, but essentially break even means your costs are equal to your revenue, meaning you're not going to spend extra money and you're not going to make any money. Your cost is equal to your revenue. Your profit is what? Zero. You would have a P of X equal to 0. Oh, yes. Okay, so how are we going to solve this equation, you guys? 30x plus 1800 is equal to 120x. Now, if we were to solve for x algebraically, we would get x by itself, right? They want us to solve the number of calculators. Probably we should solve it using graphing. Well, we don't really have a graph here, do we? But we could use our calculator for that as well. I actually think these numbers are really friendly. Let's just solve it algebraically. So just so we know the difference, I'm solving it algebraically. Okay? How would I solve it algebraically? First, that's what you would do first? Oh. So subtract 30x from both sides. Get all my x's onto one side, right? 1800 equals, what's that subtraction? Anybody? Okay. Now that means what is my profit on every single calculator? How much money am I making? Do you guys watch Shark Tank? Okay. How much money am I making on every calculator? What's my margin? I'm making $90 on every calculator, but then I have to pay off my startup costs, right? My fixed costs. So how am I going to get x by itself? By, you know, you can slash zeros, right? How many times does 9 go into 18? And then another 0. So x equals 20. So what does this mean? Yeah, well, actually, it's basically like if we sell, see, it says find the number of calculators they must sell to break even. They must sell 20 calcs to break even. So that means the cost, how much does it cost them to produce? So C of 20. This would be the cost to produce 20 calculators. What would it cost me? Yep. So 600 plus 1800 equals, what is it? What's my revenue if I sell 20 calculators? What should that equal? Oh, they have to be the same, don't they? So you just said if my cost equals the same as my revenue, I'm not making any money. I just made a lot of calculators and sold a lot of calculators, and I'm walking away with nothing, right? Okay, note that in this approach we are taking with equations. I don't know why that says that. Maybe I'm reading it wrong. We are essentially turning one equation with expressions on both sides into a system of equations. Thus, it would be helpful to learn some algebraic techniques for solving, and that's coming up in the next section. So we're taking here, actually this was a system really, but And we're making one equation out of it. We can solve it. I could also have shown you how to solve it on the graphing calculator. For this one, because the numbers are big, you would actually have to change the window, and that's a whole procedure. I don't see anybody right now with this calculator. Like I said, you will need it for Math 95, so it's a good idea to get your hands on one, and you can get them fairly cheap, probably online, or you can buy it brand new if you want to. But Desmos will work for this as well, and then you can just click on that point and you'll see the point of intersection.